Hello, my name is Andrew Moore. I am responsible for artificial intelligence in Google Cloud, and I want to really thank everyone for the opportunity to talk here today. This is a very important forum. And as you can see, I'm going to talk about my great passion for my whole career, which is artificial intelligence, and especially the four things which I've really learnt over the years are the critical factors in whether an artificial intelligence deployment is going to work or not. Before I jump into those four factors, let me talk a little bit about why I love artificial intelligence, and I have ever since I was a teenager. It's because we have all these opportunities to it's one of those science fiction-y types of things which we can actually build right now. We're probably not going to accomplish time travel or faster than light speed or contact with aliens over the next few decades. This one, we can do it right now. And it means that we've got the power to do massive and very adaptive computation to help make decisions that we individual humans just don't have the machinery in our brains to do. There are some things, not everything, but there are some things where superhuman computation or being able to consider a trillion different possibilities before making a decision are exactly what computers are good at. And so as you see on this slide, things from robotics to rapid design of new drugs to the management of cities in a way where you're going to reduce pollution, or the safe operation of all kinds of safety critical industries where we want to get death rates and injury rates down. There's all of these potential goodnesses coming out of AI, but it's very hard to make a successful artificial intelligence project. And I'll explain why. And I'll explain why for me and my team here at Google, trying to mitigate these difficulties is what keeps us going. So here are the four things I'm going to talk to you about today. And of course, very briefly, but I want to get across these basic messages. Product management is going to turn out to be really important. And this is the idea that we have to design our artificial intelligences with people in mind and how it affects an organization's operation, how it affects the lives of end users. You cannot do technology by itself. Second is trust. There has been a techlash, especially in the Western liberal democracies, around this question of what does it mean for an AI to be using data to make decisions and all the implications of that. Next, the question of life after launch. This is the real importance that if you've built an AI which is learning from experience and is getting better and better, you better make sure that you have a system in place which is monitoring that AI and which has humans in the loop, going out days, weeks, months, years, and I predict even decades into the future. Finally, AI for all. I believe that now, as we're entering the third decade of the 21st century, we're at the point where you do not need to be a PhD expert in artificial intelligence in order to build AIs. We've just hit this threshold where regular folks, people who can play with spreadsheets or can modify Minecraft, that's the level of technology skill you need in order to be able to build an AI. Not these kind of advanced things. I really need the whole world to start building its own AIs. So let's jump into each of these because they're all very interesting. Product management. Only 14% of AI projects actually end up working out. The other 86% will end up in a proof of concept valley of death, or they might not even get that far if there's internal warfare over what data can and cannot be used or how it can be used. This is why, and I'm not going to read this whole slide, this is why when you are running an AI project, you have to have the technology track and the product management track. Technology track, those of you familiar with running big engineering projects, you know about making sure you've got a good platform, one which supports rapid prototyping, but is measurable. And then you need to make sure you've got something where your scientists who've played with AI can press a button to compile it so that it runs securely and reliably in production. That's the easy bit, technology track. I say it's easy. It's easy for me because I'm a technologist all my career, and so I feel comfortable. The blue stuff, for me, a decade ago when I first joined Google, was all new. And this I've learnt through experience and through working with some of the best product managers on the planet is equally important. And when we bring this in, we're able to up our success rate of AI projects so that now much of Google, as you know, is run on artificial intelligence. And the way this happens is you're not allowed to start a project until you've got customer user journeys in place. These are things where you've really analyzed what it means to every participant. You don't let the project move forward until it crosses the various legal and ethical privacy preserving aspects. And it turns out you need to do political stuff. Usually, and this is, if you're going to learn one thing from this talk, this is the one to remember. Usually, artificial intelligence does involve huge amounts of automation. Automation necessarily means you've got an organizational change as well as a technology change. And so you cannot design your AI without thinking about how this impacts the operation of your organization right from the start. And I've seen plenty of cases where the AI is fine, but it turns out the organization is not ready for the change management for that kind of automation. And so the project sits there on the shelf. Maybe it's going to reoccur in 5 years if you're lucky. Next, trust. Artificial intelligence is that people trust. So I'm going to show you one picture which really tells a whole story. Again, you just have to look at that red and blue curve, and I will quickly explain. There is a trade-off when it comes to how much privacy you put into your system versus how effective it can be. This picture is from studies of using warfarin in a serious disease situation where the folks working on the project needed to experiment to figure out what kind of dosages to apply to what kinds of people. And in a careful analysis of the costs of privacy, the statisticians were able to show that if you increase your privacy budget, so you make less information available to your AIs, there's a cost because it takes many more patients and much more information before you can reach specific decisions. And so there is a trade-off between the amount of privacy and the, in this case, human lives, where sacrificing privacy gains you help on human lives. That sounds kind of scary, and the wrong conclusion to draw from that is to throw away privacy. The right conclusion is a huge push towards policies and technological approaches which involve things like clever use of cryptography and extremely careful use of marshalling your data in such a way that you can prove that no human ever looks at it. Those kinds of approaches can allow you to get the best of both worlds, or at the very least, shift these scary curves so that you're able to do more. For example, one of our current really surprisingly useful products is something which helps scan official documents to do identity verification for all kinds of uses, like taking out a bank loan, for example. Can you imagine training an AI on millions and millions of people's personal identifiers like their passports and their driver's licenses? No one would want to collect that data for the purposes of training an artificial intelligence. What we've been able to do instead is use the power of computer science to generate vast numbers of synthetic images simulating every kind of problem that can happen as you're using a system, and then using that synthetic data to make a classifier, which we are comfortable right now has at least 10 times the power of accurate validation than we had ever had before. So these tricks for privacy, including, for those of you familiar with the concept, customer managed encryption keys, which means data stored on a cloud in such a way that the providers of the cloud cannot access the data themselves, that only the end user can use, are really important. Next, I want to talk about life after launch. This is something which I learned a huge amount about myself through experience. As in my earlier careers, we built systems for disease surveillance, for advertising targeting, for defending against spam. In each of these cases, as we built up a team of AI experts to discover the machine learning model, be it a neural network or a decision tree or a big Bayesian network, as we built those up, we kind of sat back once we had something which was accurate enough to solve the problem, sort of breathed a sigh of relief and implemented, pressed go on putting this stuff into deployment. But in every single occasion, I ended up building a much larger team to do all the monitoring and improvement and ability to run new experiments for this machine learning system as it was carrying on through its life. For instance, of course, as you can imagine, in something like detecting fraud or spam, you actually have to have a machine learning system which is constantly guarding against adversarial attacks. But in other cases, and certainly, for heaven's sake, anything which is safety critical, you need to be monitoring all the time to make sure that your machine learning system has not started to hallucinate an effect, or, and this one is really serious, get the causal nature of this thing implies that thing wrong. And so this is a model which we have sitting up in our walls in Google, and of course nowadays on post-it notes around all our desks, to do with the design of a machine learning platform. Is certainly there to support the initial data science geniuses who are coming up with those models in the first place, but most of it goes into making sure that you've got something which is running securely. You're able to understand and identify a problem if it starts to behave strangely, or one of your customers is complaining that something really weird has happened. You have to have the diagnosis tools for that. And then you also need a platform where everyone in your organization can ask the question, hey, would this thing be working better if it could also detect, say, the weather? Or would the AI be helped if we made sure that we were filtering out the effects of this very volatile variable? And people can ask those questions, and you can experiment to find out if it helps. And then you can do a safe launch to launch a new, better version of the machine learning model. So I think this is probably something which I would regard as a key thing to remember in all of this. When you're about to run an AI system, or you're in charge of an AI project, most of your thinking right from the start should be what you're going to do after it's been launched. And that exciting time before it's been launched is important, but being able to operationalize that machine learning system afterwards is even more important. Finally, this question of AI for everyone. We computer scientists are sort of notorious for taking professions, figuring out parts of those professions which computers can do better, and making that happen. Here's ironic and good news. We've done it to ourselves. So when it comes to all the messy work needed to figure out how to mess with your data in order to get the most accurate model, or choose which kind of machine learning method to use, or to automatically figure out which variants of a machine learning model to use, or what information to pay attention to or ignore, all of that stuff, which is the manual daily life of a data scientist, we can provide additional tools to actually create an autonomous computer replica of a data scientist. This kind of system is called an AutoML, and the idea is that here, someone who's doing an important thing in an organization who needs to train up a system to do something should be able to, if they can't afford or they don't have access to their own data scientists, should be able to build stuff themselves. And I encourage everyone to play with these things because they're really fun and they do take away the grungy work. I want to give an example now, which I think is a perfect case study of someone doing something interesting and useful without having access to machine learning experts themselves and what comes out of it.
The main challenges facing wildlife today is habitat loss, climate change, and threats from the illegal wildlife trade. ZSL's mission is to create a world where wildlife thrives. We work in over 50 countries around the world where we empower and inform people to help stop wild animals going extinct. We have been working with Google to look at how we can use Cloud AutoML to really make a difference.
We use camera traps to monitor the state of the planet. They are tiny little digital cameras hooked up to a little motion sensor, basically. So when an animal walks past, they snap a little photo, which you can then retrieve at a later time. As well as telling you about how abundant different species are, they can also offer behavioral insights as well.
One camera trap study generates hundreds of thousands of images. So over 6 months, you might get 500,000 images that you need to sort through and analyse.
You've got to go through every single image. You've got to label them, the time, the date, what it contained, which camera it was. At the moment, it takes months.
If we can speed up the analysis from 6 months to just days, that's revolutionary in our conservation efforts. Google Cloud AutoML allows conservationists who are non-coders to use machine learning to create image recognition models to identify species in camera trap images.
These are images that I have labelled, and they're going to teach the AutoML algorithm what different species look like.
If you can just AutoML it, you could go, show me the images that are empty, show me the images that have the animal that I'm interested in. You can actually use your scientific research and conservation time to do conservation rather than doing data analysis.
We might use the data to actually influence policy change or conservation action. AI is going to play a really big part in collecting all the data together from wildlife conservation sites around the world. And if we do that in real time, we can use AutoML to really monitor the pulse of wildlife across the planet.
So that's it. Thank you very much for giving me the opportunity to talk about these passions in my life and things which I think are critical for anyone who's going to be responsible for artificial intelligence. Bottom line, product management techniques to make sure you're bringing in the humans and the organizational dynamics, trust, making sure that you can set up your system so you're not violating users' reasonable expectations of privacy while you're using your AIs. The real importance of ML operations. Use a platform which helps you develop a great machine learning system, but then maintain it and keep it healthy for the rest of its life. And then finally, this real call to action that you do not have to have some fancy PhD to use machine learning or to build AIs anymore. We're now in a world where I expect creative subject matter experts to be able to build their own AIs. So with that, I'm done. Thank you very much.